Hi everyone, and welcome back for the afternoon sessions. Are you awake? Are you sure? Okay. Now the light's going down, so it's perfect time for a nap. Okay. Of course, we are doing a very boring talk with a lot of diagrams, maybe a live demo at the end, so you might sleep. Okay, hopefully not. We'll try. I'll do my best. Hi everyone, I'm Matteo Collina. I work for a company called Platformatic. Check us out. What I do a lot of Node.js. So all my demos will be using Node.js. If you are using Rust or Go or Ruby or PHP or Python or Lua, I don't know. Yeah, everything can be applied there as well. Okay, so there is nothing specific. I am part of two boards, open source. So I'm part of the OpenJS Foundation and the GraphQL Foundation also. And more importantly, I'm chair of the Node.js Technical Steering Committee. So if you have any questions about Node, I can probably be the person to ask. You're all using my software, by the way. So either directly or indirectly, so somebody will start collecting some offers for the cause. But we're here today to talk about GraphQL and something very, very specific about this fantastic language and production servers. We are talking about GraphQL subscriptions, okay, and specifically GraphQL subscription over WebSockets. By the way, this is great. It allows a phenomenal way to implement, I don't know, CQRS systems and a lot of other things. How do they work? You send your mutations and things. You send your mutation to alter some data, and then you are subscribing to for some information, and you receive the updates, and the other person there receive the updates. How many of you have used subscriptions before? Okay, everybody in the room almost. I'm sorry for all of you that didn't. This is a lot about subscriptions, okay? So, what happens, we have multiple clients, okay, connecting over WebSocket to one or more GraphQL servers. Because we need to scale up, to scale out, we are using a pub subsystem, can be Redis, RabbitMQ, or Kafka. And, we have wrote a Kafka library for JavaScript because the previous one were not good enough. So we know the problem. And of course, somebody is going to publish it to that pub sub layer, okay? We don't care for this talk. That can be anything, okay? So somebody will publish that data, okay? Not our problem for this talk. So let's say that we want to get livestock prices, okay? And based on the livestock prices, we want to, our user need to do some decision making based on those stock prices. So it's actually pretty important that the data is actually always updated. So, we do our nice subscription and we get some data, okay, out. However, there is unfortunately a big problem with this design. A user, your developer, will start coding using this API and rely on the message being delivered, okay? Oh, there will always be delivered. So I can just subscribe. And will automatically reconnect, and I will get the updates. According to Cloudflare, 20% of TCP connection goes down. I didn't write the stat. Which means GraphQL subscription can and will absolutely lose messages. You cannot rely on them providing accurate information. What does it mean? Well, one could say, okay, I start my subscription. Before I do a query, and then I do a subscription. But if I do that, then by the time I start my subscription, the data might have changed, I might have lost some messages, and I'm back on the starting point. So it's very hard to know and be sure that you have the latest information on your subscriptions. Dang. What can we do? Well, we need to do a little bit of excursus on distributed systems and, some university stuff. I'm sorry if I'm going to bore you to death. So we are going to talk a little bit about message delivery guarantees. The first one is called at most once, okay, or fire and forget. What does it mean? You are receiving a message, okay, but the server does not know if you have received it. You have received it, you have not received it, you have processed, you don't have processed, it doesn't matter at all. Okay? It might be lost, who cares? UDP, right? In some cases, in some language, in some protocols, these might be called quality of service level 0, because it's the bare minimum you can do. Typically, this is for MQTT. I have a lot of experience on that stuff. If you search MQTT on NPM, you probably will find me. Anyway, now, the next option is at least once, okay? Which is a series of exchanges between client and servers for the client to tell the server that it has received a message. Okay. This means that the client might receive some duplicates, but it will absolutely, at least it will receive all the data. And then there is a third mode, which is called, at least once is typically called quality of service 1. And then we have exactly once, which does have even more complex set of protocol dance between client and servers to guarantee to tell both the client and the server that they have received the message only once, and only once. Okay, so let's describe a little bit what's happening. So we have our server, we have the network, we have the receiver, okay? Best effort, this is best effort. The sender sends a lot of messages, okay? And there is no retry, no acknowledgement, okay? And so it's very basic. If a message is lost, it's lost, okay? That's it. This is how, by the way, how GraphQL subscription works today, okay? The server sends you an update, and if the connection drops in the meanwhile, up to you. At least once quality of service. How does it work? You have your server, okay, that sends messages, okay. With quality of service 1, you see that there is an ACK coming from the receiver back to the sender, okay. It means it tells the sender, I have received this payload. So if a message is lost, okay, and the client reconnects, okay, it can the sender can retry again in sending the data, okay. And you see here, okay, you see ACK2 is lost, is not received, okay. Because it's not received, the sender will retry message 2, and if message 2 is a duplicate, message 2 is a duplicate, and then it will receive an ACK. Okay? Does it make sense? Okay, great. It also matters if timeout occurs and so on and so forth. Okay? Great. Now, I'm not doing the graphs. I didn't do the graphs for exactly once, guys. Otherwise, I will stay along here forever. Okay? Also because it's not really relevant for the rest of the discussion. Because we need to make, how can we make GraphQL subscription honor at least one semantics? We want to be able to guarantee that our server, our clients receives all the messages. We don't care if they receive them twice, okay? But at least we want them to receive at least once, okay? So let's provide, how can we provide at least once semantics for GraphQL subscriptions? While GraphQL subscription protocol does not do it. So we need to build something on top. Big problem, by the way. So first of all, we need to have each message have an identifier, okay, or a cursor, okay, in terms of using a little bit Kafka lingo. Guess Kafka. I'm sorry. We need a cursor, okay, to do it. Then, when subscribing, okay, the client should send the last known cursor to have all the message replayed until then. Sounds simple, right? how would it work? We have the client, the server, and a thing called the event store, because this is important, okay? We are, the client is subscribed to events. We send our subscription message with the cursor. The client maintains, we receive the message with the last known cursor. The client stores the cursor locally, okay? And then it keeps updating the cursor. When the connection is lost, the client can send the cursor back. What does it mean, though? Okay, it means that the server will keep publishing data and storing events in our event store, okay? And then, when reconnecting, the client will reconnect and say, oh, but I want from 42. And then the server needs to start replaying from 42. And it can do that in band inside the subscription protocol. So you have this kind of replay phase where the server will start sending back all the things that happened. You send 43, 44, 45, and then resume the live stream. Okay? Does it make sense? Okay, great. So this is stateless and resumable. Okay? You know, there is some state involved. You know, I have the server needs to record all the messages, and I have the client that needs to store its own state. Where should I store this state? Well, it depends on your application. You can store it on local storage. You can just keep it in memory. If you keep it in memory, you will lose it on refresh. So up to you where you put it, okay? But you need to put it somewhere that is safe. Or not, depends. Again, there is a problem, though. What's missing? Axe. The problem with that architecture, which is more or less simple, okay, it assumes that the server will keep all the events and all the data forever, or up to a window that is, I don't know, and then they are evicted, okay? This is a relative problem. However, there is no in-band way for managing these acts, okay? So in reality, what I would do is you will need to implement these as mutations on top of the protocol. But it will be incredibly better if some of this kind of system could be implemented at the, inside the wire messages of the WebSocket, so there will be no real changes to the schemas and possibly the mutation schemas on top. Anyway. There is another problem. So this is half of the talk. Next half of the talk. There is a problem, okay? And you all have had this problem if you have shipped GraphQL subscriptions at scale. If you are deploying it in a Kubernetes cluster or ECS or whatever, you have probably had to deal with scaling, okay? How do you scale this? Because you cannot really easily use the Kubernetes autoscaler. Otherwise, you will lose messages. But if you lose messages, you will have angry customers because they will lose some data. So you cannot shut down those servers until you have drained all connections in a safely way. So, ouch. I can scale up easily, but I cannot really scale down. This does not really work well in case I want to grow up and down my system. Note that you might see some of this problem too if you implement it with a concept called sticky sessions. You probably have played with this sometimes. So anyway, the problem is if you want to scale it, but I don't want to close any disconnection to my customers. How can we do that? Okay, can we use the same concepts to solve the scalability problem too? We can, but let's describe the problem first. So we have the update, so we have an affected client, so we have a client connected, okay? And right now you have a load balancer, okay? Typically, usually this is deployed with sticky session for some reason, but you know, even if it's not, it doesn't change much, okay? And it's connected to these GraphQL servers that maintain the state for this connection, okay? But this crash or it's being terminated by the autoscaler, it goes down, whatever, and it gets disconnected. And our pub system, event store, whatever, based on Kafka, okay, it's over there, okay? Now, we need to, the client then will need to be reconnecting to another peer. But in this process, it will lose some messages and some data. Depending on how friendly your customers are, this can cause you an incident or not. Okay? It's, if your customers are, if you're a consumer product, maybe somebody will not even notice. But if it's an enterprise product, somebody can get upset with this. So, how can we solve it? Well, what we can do, we can add a proxy in between, okay? And this proxy maintains the connections, okay? And with these connections, okay, and the connection state, specifically the state of the last nodes of the cursor that we had before, okay? Now, and this does go to the load balancer, which we don't need sticky sessions at all, okay? And when the connection, when the server dies or crash or is terminated, okay, it can reroute the connection to another one, but because it knows the state of the last message, it can reconnect and from where the last connection was dropped. In this way, the messages can all be flown back. Let's go, okay, yeah, sorry. Let's go and see this. So, this is how the proxy would work. We have a message, okay, the subscription, okay. The proxy sees start tracking, can do inspect the query, identify the cursor ID, okay. Then it, when there is a message coming out, it maintains the last received ID from the message. This is the cursor, whatever, okay. Then, automatically, the connection on the other side is kept alive, and it reconnects. It automatically issue a subscription again underneath. So there is absolutely nothing, no disconnection happening on the other side. Why somebody will, so somebody, you could say, oh, but if we do this, we are just shifting the responsibility from one place to the other. Yes, we are, but also we are shifting the responsibility to a place where it's its only responsibility, okay? On your GraphQL subscription server, probably you have a lot of other things happening at that point in time, a lot. Okay, you have all your business logic and so on and so forth. This thing is way smaller to scale and manage, okay? So, to be clear, we are just shifting the problem, but shifting to a place where it's more manageable. Okay. Now it's time for me to do some live demos using Node.js, okay? Sorry, I've lost the time. Okay, great. Using Node.js and Fastify, which is a framework that I created for Node some time ago. Okay, and I have a URL for all the demos. Okay, so if you want to play along, you can play along and follow. Okay, and can you enable me this mic, please? Hello? 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 Okay, great. So, it's time for the demo gods, okay? Hopefully the demo gods will be with me today. Okay, I have 4 terminals. Hope you can see all the terminals. Okay, first of all, I am going to, I don't remember anything because, you know, it's some time has passed. Okay, yes. So first of all, I'm starting a very simple basic GraphQL servers, server simple, okay? And I am client, running a small client without resume, okay? And then client without resume, okay? And if I can type here, you get the other one. Makes sense? It's a basic chat, okay? We get the same messages on both sides, okay? Very basic GraphQL client. Let's see how that's implemented. So this is the client. The client, when it starts, it will open a WebSocket, okay, and send the connection init payload using just the low overhead things, and so on and so forth, okay? Yep. So here we go. This is our client. Now, and this is the query that's going to send. So we send on message and so on. Okay? Perfect. Now, however, let's see what happens with a server that that can crash all the time. Okay? Well, not all the time, but can crash. So we are now started, and we can play. You see, this is the same as before. But every now and then, this service will force some disconnections, and you see that it's getting some message, and some messages are lost, okay? While they are you see that there is some messages being lost in the process, okay? So we have lost some messages, okay, and these two systems keep dying all the time, okay? So what can we do? Well, we can enable the, you see here, I can connect by passing the ID of the last message known. So I implement the Resumable subscription, and you will see this in the, what is it? Last message ID. Okay, you can see that if we are tracking the last message, this will be sent. Okay, so let's enable the last message tracking so that it implements this protocol that we have been defining. We have defined, so we can do client with resume. Okay, here we go. Okay, now, you see the messages are going. Okay, now is this connected? Okay, and now you see here it got all of them. Okay, so it automatically gets all the messages that were lost because when we reconnect, we get the data. Okay, so this is, and this can keep going essentially forever. In this repo, we have a full demo that runs it, I don't know, for 20,000 messages that verifies this protocol is safe and sound for this use case. So, okay. Now, let's talk a little bit about the, however, to support this, the client needs to be aware of that change, okay? So it doesn't protect them from the client, from the server crashing. So to do that, we need to do the proxy. Okay, and we're running the proxy, okay? Now, let's run again the client without resume, but connecting to the proxy itself, okay? So we can run that, and to proxy, okay? So we now, both of those are now connected to the proxy, okay? Now, if I run them, you see that this never disconnects, okay? But if you see here, we see that the client is reconnecting underneath all the time. And is reconnecting, resubscribing, resending all the things underneath, okay, automatically, without anything, without losing any messages whatsoever. So let me show you how this is implemented, because it's actually very simple, okay? So we need to, we're going to use a few libraries. One is called Fastify, as I said. There is a library called Fastify HTTP proxy that allows us to build a very simple reverse proxy system, but with data mangling, data inspection in it. So it's actually very, very useful technique for that. And this library called GraphQL Subscription Resume that we wrote that simplifies all this logic. Okay. Now to set it up, we need. Okay, we just need to create a Fastify HTTP proxy with these chooks, WS Reconnect and WS Hook. No, WS Reconnect adjusts the options, okay? It tells us to reconnect, okay? And WS Hooks tells us what to do when that happens, okay? So when we connect, we intercept it, blah, 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 do nothing, but, you know. When we disconnect, again, we remove all subscription from the known store, okay? On reconnect, okay, we can track this, the client ID, okay, and restores the subscription, okay. And then when there is an incoming message, we verify if it's a start. If it's a start, we need to track that subscription. Okay, you can see here, we add it to the state, and then when there is messages coming down from the other peer, and we need to send to the client, we need to update the subscription state with the last ID. So, and this goes on and on and on. The state, what is the state that we mention, is essentially this stateful subscription, which comes from the GraphQL Subscription Resume module. Okay, how is that implemented? Well, let's see, so that you can see that's it's not that straightforward. Okay, it's straightforward, but there is a little bit of logic inside to track all the things and parse them out and stuff. It even rewrites some of the GraphQL queries on the fly because it's fun. Okay. You need to do that to do these kind of things. So you need to rewrite the GraphQL queries on the fly to get it going. You can see it in here. GraphQL, Platformatic, Resume. And here you can see that it has a lot of, when there is it does a little bit of rewriting and things like that on this topic. What is it? Yeah, injected keys. You see here, we basically have to rewrite the config, rewrite a few bits, because unfortunately it will not work otherwise. Okay, this is all. I think I am on time, so half an hour. I'm almost perfect on time. Few boats. What we do at Platformatic, we create something called VAT, is the Node.js application server to run your Node.js app. It basically wraps them in a nice cocoon, and handles all our problems for you. You can try it out. We will have some benchmark and case study coming out later this year, but things are pretty useful. Then I also wrote a free book, The Definitive Guide for Node.js in the Enterprise. This is free. You can just pay with your email, so we can spam you. Okay, but if you are interested it covers a little bit also GraphQL and stuff, but if you are interested for doing Node.js at scale, this is what we do. Okay. Yeah, I don't know if there is a Q&A, but I will be happy to take questions now. I don't know if you have time, so somebody from the org can tell me. I will be very happy. I don't know. Are there any questions? Hey, okay. So the question is either, is this problem solved in other languages other than Node.js? As far as I am aware, no. I have not. This, I think, is now solved. Like you can solve this, this problem. The solution that I proposed is not. It's a solution built on top of the protocol. Okay. And it's very easy to implement in all sorts of languages, of course. You just need to follow the same reasoning. It has nothing specifically special. I don't think of many implementations that do that, okay? I think somebody would have some companies would have solved this problem, okay? Because if you don't solve this problem, you are in shipping GraphQL subscriptions, you are in a hard trouble. Okay, you will lose messages, but I don't know if there is any framework or something that is doing it, as far as I'm aware. But if you know, please tell me, because when I was researching this topic earlier this year, it was not there. So I couldn't find anything, at least. Yes? So the question is, can this run on other runtimes? Frankly, I did not check. Okay, that's my take. Node.js compatibility is their problem. So if it doesn't open an issue on them, okay, it's. I am a Node.js person. I test my things on Node.js. Most enterprises and companies out there use Node.js. So I'm, I'm an open source person too, and I use open source I work on. Hopefully that gives you an answer to that question. There was another hands up, I think. Yeah. Okay. The question is, how do you scale the proxy? Okay. So first of all, the first problem. So as we said, we just shifted the problem. Okay. So. This means that the proxy responsibility now is essentially just to keep those connections up, okay? Which is way less than handling all the subscription law. It's way, way less overhead than just keeping the connection logic open. As you have shown, there is no GraphQL. It's just a very simple Fastify application, okay? It does not have a lot of logic in it. It does not have the full GraphQL query planner, executor, and everything in it, okay? So there is a lot less happening there. So it has less scaling problem than the full-blown servers that has also, so we have shifted the responsibilities, okay? So this works relatively well for a good chunk of scale, okay? However, at a higher traffic level, okay, this solution would involve implementing a consistent hashing solution to be able to handle some of these cases. But it's very, like when we are talking, millions, millions and millions of connections, probably tens of millions of connections. The typical solution is dimension for your type of size and essentially adopt a more or less fixed scaling solution to that layer. So don't automatically auto-scale this. If you need to do that, you will need to do a lot. It's a lot of work to scale a WebSocket server at that point in time. The solution, part of the problem, it's lowered a little bit by our VAT application server because it allows you to spin up multiple Node.js threads all listening to the same socket. So you can very easily essentially have multiple threads on the same box without the overhead of cluster and so on and so forth. Because of that logic, it's actually less, you can essentially throw more CPUs at the problem, essentially, in a much more straightforward way. So yes, it is a problem. You will need to scale up and write a much more complicated layer for routing those connections, okay? In using something like consistent hashing and things like that. But it's, at the scale we are working on, it's not, we could get away with a fixed scaling solution, beefy machines, and it's, if there is more traffic needed, add servers, and then spin them down during the night, essentially. There was another question. Oh, same question. Okay. It's, hopefully, I answered. If you want to chat a little bit more about use cases, I am available after the talk. Okay. Yep. There any more questions? Cool. Okay. Where do I store the state of connections? So I have two, in the proxy or in the client? In the proxy. So the question is, where do I store the state of the connection in the proxy? This is actually a very, very interesting question, okay? There are two options in practice, okay? If I have an out-of-band client ID that I can rely upon, So for example, a user ID. So I want to know what is the last message that I sent to this user, okay? What I can do, I can put that information in Redis with the last message ID in place. And with that, when that user reconnects, it will get the last messages, okay? So it does not need to change anything related to that specific user, making it completely unaware for the client. Now, the problem, why I'm mentioning this case, it's very important because GraphQL is usually built not for, depending on your usage of GraphQL, you might want to expose the full GraphQL capabilities to end users via APIs. If you do that and you want to provide those kind of capability with subscriptions, having that might be very useful to you. So that they just specify the ID and then they get you get all the messages, okay? And it's actually very useful. And you put that ID, that user ID, and the last message in something like Redis, okay? Works very well for this kind of state. Otherwise, you keep it in memory because it's connected to the socket, okay? When the user reconnects, well, if the user disconnects, the client will need to handle the protocol dance for at least once delivery. Hopefully I answered the question. Fantastic. Okay. Oh, I have more questions. But is there a next speaker? There is the next speaker up, I think. I don't know. I don't know what time we're supposed to finish. 3 minutes to the next talk, so I'm very good. Okay, I can answer the last question. Okay, no, there is no question. So, please, thank you very much.